Hello everybody, and thank you for joining me. Today we're going to be going over a definite integral that involves an integration with substitution. And so what we're going to have is the integral from 0 to 1 of x cubed times x to the fourth plus 2 cubed dx. So now as we look at this, I would point out first that if we did want to integrate this, the goal is to find an antiderivative, to evaluate at 1, and then subtract off evaluating at 0 in order to get the area under the curve. Now, the way we're going to do that is, well, we have a couple options. Is we can multiply this out and actually distribute the x to the fourth plus 2 cubed. We can simplify it, and then we can integrate using a power rule and factoring out constants and distributing across sums and differences. However, what I'm going to do instead here is I'm going to use a substitution because I do have an inside function here, and I am multiplying by its derivative. So, before I continue on with this, I'm actually going to answer a related question. That is, I'm going to answer the question, what is the antiderivative or the indefinite integral of x cubed times x to the fourth plus 2 cubed dx? The reason why I'm going to do this is to avoid some of the substitution with endpoints, and I'll bring it back when I'm done to answer my original question. Now, if I'm looking at this one, what I notice is that, yes, I do have an inside function. And that inside function is I is x to the fourth plus 2. Now I'm going to use I here for inside function because it makes sense to me. If you'd like to use a different variable such as the common one is u, feel free, but I for inside makes sense to me. Now that I have my inside function, I'm going to find my differential di. So di is going to be the derivative of x to the fourth plus 2 with respect to x, which is 4x cubed, times the differential dx. Now, as part of this process, I'm then going to solve for dx. So dx is going to be di over 4x cubed, which will then allow me to simplify my original integral in order to find an easier integral so I can find an antiderivative. Now, let's go ahead and do that substitution. So what we get is the integral of x cubed times I cubed, and then di over 4x cubed. So what I've done is I've substituted in I substituted in dx in terms of di and x. And so the goal here was to leave everything else alone in the hopes that we could simplify and get rid of it. And lo and behold, we can get, well, the x cubed and the x cubed cancel out. So if we cancel those out, we also have a 4 on the bottom, so we can factor that as a 1/4. So we end up with 1/4 times the integral of I cubed di. And now we do in fact have a relatively easy integral. We just have to integrate I cubed di. Alright, I erased the bottom things just so I could have some more room. And so if I want to integrate I cubed, it's going to be a power rule. So I'm going to add 1 to the power, and I'm going to get I to the fourth. Divide by the new power is 4. And so I get I to the fourth over 4. Now remember that I had the 1/4 from before, so I'm going to carry that over, and I'm going to have 1/4 times I to the fourth over 4. And because I'm finding an indefinite integral, I'm going to have my constant of integration c. Now the I was a variable that I introduced in the problem, so I need to get rid of it. So what I'm going to do is just say, well, 1/4 times 1/4 is 1/16. I is x to the fourth plus 2, so that to the fourth, plus c is now my general antiderivative of x cubed times x to the fourth plus 2 cubed. And so now we have found the antiderivative of this function. Alright, if we go back to our original problem of finding the definite integral from 0 to 1 of x cubed times x to the fourth plus 2 cubed, then what we get is that we already found an antiderivative of this, and I just need 1. So I'm going to use the x to the fourth plus 2 to the fourth over 16. I don't need the plus c because I only need one example. and then I'm going to evaluate from 0 to 1, which means plug in 1, subtract off plugging in 0. So if I plug in 1, I get 1 to the 4th plus 2 over 16 to the 4th, and then minus 0 to the 4th plus 2 to the 4th over 16. And if we simplify this, we're just going to end up with 1 plus 2 is 3. 3 to the 4th is 81. So I get 81 over 16 minus 0 plus 2 is 2. 2 to the 4th is 16. 16 over 16 then. And so if I subtract these, I get 81 minus 16 is in fact 65 sixteenths. Therefore, what we found is that the definite integral from 0 to 1 of this function, or the area under the curve of this function, is going to be precisely 65 sixteenths. Alright, thank you for joining me for calculus practice. If you'd like to see more problems, you can check out the rest of this playlist available up here. Also, please sure to subscribe to the channel so you can see when we have more of these coming up. In addition to that, you can also check out the link available in the description below to see the written version of each of these problems so that you can pull that up to follow along with the video or to do on your own for extra practice. Thank you and good luck with your studying.